Hello my dear students, I am B S Pandey. Here my dear students, we are in lecture number 79 of series of video lecture of standard 12. Student, today we will start with the average power of LCR series circuit, and then we will discuss a term that is called power factor. Okay, and then after we will solve few very important questions that are based upon LCR individual and LCR series circuit. Okay my dear students, so let's start today's lecture. It is lecture number 79 of chapter 7 NCERT, alternating current. Okay, my dear students, as I told you, we are starting today with the average power. Average power of LCR series circuit. Alright. Okay. Now, in this LCR series circuit, as we have discussed in last lecture 78, we combine LCR in series, then phase difference between the net voltage and current we obtain as the phi. Okay, if we supply input as E naught sine omega t in this LCR series circuit, LCR E naught sine omega t, the instantaneous current I t that we have to that we have already, and the current we obtain as I naught sine omega t plus phi. Here phi is the phase difference between voltage and current. My dear students, this is the net voltage, actually ET. We are going to find out the average power. We know that formula for the power, it is PT dt over dt. For full cycle, my dear students will write as PT dt for full cycle to dt. Alright. Now, we are having the formula for this PT dt, we know as ET into IT dt over dt. Okay. Now, we are having the value of voltage and current as E naught, and this one sine omega t times I naught sine omega t plus phi. Okay, it is dt divided by t. Could you write? Look at carefully. Yes, we can write, my dear students. Here we can change this equation using trigonometric formula, dividing, taking this constant E naught I naught outside, and this t will be also the 2 times sine omega t plus phi and sine omega t dt. Can you write, my dear students? Yes. Then it is 2 sine A into sine B, and we'll apply the formula. It is E naught I naught over 2t, and for this one we are going to apply here the formula, the integral value cosine A minus B, it is omega t plus phi minus omega t minus cos a plus b, it is twice omega t plus phi, alright, times dt. Now further, if you are understanding till here, my dear students, then you can do the integration by yourself. I know this is not very difficult for you. It is E naught I naught over 2t will integrate here the cos phi dt. You can see it is omega t will be cancelled out, cos phi dt minus here the cos, again integration, cos twice omega t plus phi dt. Alright, for the full cycle. Okay, now this will be E naught I naught over 2t. This is cos phi constant and dt becomes t minus, it will be the sine twice omega t plus phi divided by twice omega for the full cycle. My dear student, for full cycle we know that the sine value will give you the zero amount. So it is E naught I naught by 2t times cos phi into t. Remember, this is not the angle actually, and this value becomes 0. Now this is the mathematical thing. I hope you are not getting any trouble while understanding this integration. Okay, t will be cancelled out, my dear students, and we can write here now as E naught I naught over 2 cos phi. My dear students, you can recall the formula of power we got as the E naught I naught by 2, but here this cos phi is an extra term, and we know that this cos phi, this phi actually will change and the entire value will change. Here the cos phi, we know that the cosine value varies from -1 to +1. It means this power will vary like that. But this total amount remain constant, and this power is depending over this cos phi. That's why this cos phi is termed as the factor on which this power depending and known as power factor. Alright, so this cos phi is termed as power factor. My dear students, you can use this formula in all the circuits in AC for individual resistor, individual inductor and capacitor as well. Let me convert this formula in RMS value. It is as E RMS. What we can write, actually try to understand, we can write E naught by root 2 times I naught by root 2 times cos phi. Yes, can write, my dear students? Yes. And this E naught by root 2 is nothing but the E RMS times I naught by root 2, it is I RMS times cos phi. And then this is the generalized formula for the power dissipation through any circuit. My dear students, this phi, we are very much familiar with this phi. If we are talking about any circuit which is having only resistor, then we know this phi, which is the phase difference between current and voltage, it becomes 0. Cos phi, phi becomes 0. And in that case, cos phi will be how much? 1. So the power will be maximum, because we know that the value of cos phi, maximum value of cos phi should be 1. In that case, the power will be maximum dissipation. In which circuit? In resistive circuit. When we talk about the phase difference of inductive or capacitive circuit, then we'll get directly the average power and it becomes 0. As we know that in inductive circuit, the phase changes with pi by 2, and in capacitive circuit also the phase changes by pi by 2. In both the case, this cos phi will be how much? It is 0. Then the power will be 0, and then this current will be termed as wattless current. Okay, my dear students, whenever you use to find the wattless current, remember this is the voltage, but this factor actually defines the wattless current. This current becomes wattless. That's why the amount of wattless current is termed as this one only. If you want to write the wattless current for any circuit, wattless current, so it will be IRMS times cos phi. Remember, this is the value of wattless current. In any circuit, if the phase it is given inductive or capacitive, we know that the wattless current, then in that circuit you can measure the amount of wattless current. Okay, my dear students, but our aim is to reach to the general equations of this power factor. Alright, my dear students, so let me convert this one in the general terms. Okay, so my dear student, now I am going to discuss here about the power factor for different circuits, that is resistive circuit, capacitive circuit and inductive circuit, one by one. Okay, my dear student? Yes. So, case 1, if it is the case of resistive circuit, for resistive circuit, my dear student, we know that phase difference it is 0 for resistive circuit, and power factor, that is cos phi, becomes cos 0, and which is 1. Then average power will be ERMS times IRMS for resistive circuit. Okay, case 2, for capacitive circuit, we know, my dear students, for capacitive circuit, phi is, yes, what should be the phi? Pi by 2 minus or plus. So, we know that current lead in capacitive circuit, so it is pi by 2. But whatever may be the value of phi, pi by 2 plus or minus, the cos phi will not change. And here the power factor we can write as cos pi by 2, which is 0, which gives the average power as 0. Alright, and case 3, my dear students, for capacitive circuit, we know that phi it is minus pi by 2, and power factor, my dear students, it will be cosine minus pi by 2, again it is 0, and the average power, it becomes 0. So here we discuss one by one the power factor for each circuit under AC supply. Now, my dear student, remember the phase difference, it is not always the pi by 2, it might be you will get any different value, pi by 4, pi by 3, pi by 6 and whatever. Okay, so we will solve few questions on the basis of that one also, but here first we are going to study here the power factor in terms of impedance. Power factor in terms of impedance. Now we are able to study the power factor in terms of impedance. Why? Because we know that for LCR series circuit, cos phi will give you the power factor. So we are going to find out actually the cos phi. We know that is the power factor. Do you remember E net for the LCR series circuit, my dear students? Yes, it is E L minus EC J cap plus ER I cap. I hope you remember. Phasor diagram will represent in this way. This is the ER and this is the E net. Alright, this is the E net, whereas this one give you the value EL minus EC. When we write tan phi, what we get? The tan phi, it is, if this is phi, alright, this is phi. Remember, this is the net voltage of LCR series circuit and this is the current, you can write, or the voltage across resistor. This particular value will give you the ER and this one it is EL minus EC and this one is E net. Okay, so this was E tan phi, it is equals as perpendicular over base, it is EL minus EC divided by ER. Am I right? Yes. But what is power factor, my dear students? We know that power factor is nothing but it is cos phi. So we are going to find out here the power factor in terms of impedance. Remember, you can give the heading power factor in terms of impedance. Alright, yes, in terms of impedance. Alright, so look at here carefully, this triangle, the cos phi, it is nothing but the base over hypotenuse. The base, it is ER over hypotenuse, it is E net. Could we write, my dear student, this one as ER over E net? We know that in LCR series circuit, current remains same. So this can be also written as the current through resistor. It is same as the current through the equivalent circuit and it is nothing but the Z. I hope you understand. Z is the equivalent resistance multiplied by the current will give you the equivalent voltage, that is the net voltage. It will be the cancel out and cos phi, it is R over Z. This one is another very important formula. When we talk about the power factor of resistive circuit, my dear students, listen carefully what I am telling you. When we talk about the power factor of resistive circuit, then this Z will be, for this resistive circuit, Z is equals to R. Am I right? Yes, Z is equals to R. Then we can write cos phi as R over R, which is 1. Alright. But when we talk about the capacitive circuit, then its resistance becomes XC. XC for the capacitive circuit. And impedance in case of capacitive circuit, it will be the XC, remember. And in that case, cos phi, it is R, that is the resistance, over the impedance, it is the XC. Almost you can find out the same value if you compare this one. But when we talk about the cos phi, that is the power factor of individual capacitive or inductive circuit, what we see, it is pi by 2 and it almost around the very less value. So we never try to compare this value in this way. But this one is very, very important for the combined CR or LR circuit. If we are having the C and R joined together, then what will happen? The R is not going to be changed, but this XC will change and it becomes root under XC square plus R square, that is the impedance. And of that CR circuit, you can find out the power factor. So in terms of impedance, we can write the power factor as this one. This one is very, very important equation, my dear student. Alright, cos phi, it is R over Z. Now, after knowing this particular theory, this was the theory segment of LCR series circuit. Now we will study in theory segment the tuning of circuit. How to tune a circuit, that is the sharpness of resonance. Okay, but before that, in today's lecture we should solve few numerical questions so that we will able to handle questions of board or competitive level. Okay, student, if I'll give you for inductive circuit, capacitive circuit or combined circuit, the equation of current or voltage, alright, could you find the unknown quantity or equation for the unknown quantity? Suppose if I'm giving you the equation of current and you have to find the equation of voltage. Okay, so let me solve few questions on the basis of that one. Here are first question. You have to find the equation of voltage. I am giving you the equation of current. I have given a capacitive circuit. To solve this type of question, my dear students, you should have in your mind how the current or voltage lead or lag in particular circuit. Okay, this is the capacitive circuit. Here 100 microfarad capacitor is connected with the source. Alright, 100 microfarad capacitor, it is connected. Now, if the current obtained as the function of time, it is IT as if the current is given. Alright, 10 sine 100t plus pi by 6. Plus pi by 6. Then you have been asked to find the equation of voltage as a function of time, the first, and second you have to find power dissipated in this circuit. How will you solve this type of question? Try to understand how to solve this type of question, my dear students. So here, as we have to find the equation of voltage, we know that it should be like E naught sine omega t plus or minus phi. Alright, might be the phi is 0, might be the phi is some value, but we know that the phase difference, it should be not 0. Alright, so what will be the equation? We have to find first E naught, and omega t already it is given. We have to find the value of phi. Okay, let me solve here. To find E naught, we need to find the value of I naught, which is given. But E naught and I naught are correlated as E naught I naught into resistance, and here the capacitor, so capacitive reactance Xc. If you will have the value of Xc, then you can write E naught. So Xc, we know that it is 1 by C omega, 1 over C, it is 100 microfarad 10 power minus 6, and omega, it is how much? 100. You can see it is 100. Alright, so it is 100 ohm, I think. Xc, you should cross check my calculation. Process will be no doubt correct. So it is 100 ohm. What is the value of this Xc we got? Actually, what we got as this 100 ohm, it is reactance. Now E naught, it is I naught, which is 10 times 100, so it is 1000. Now my dear students, we know that if this is the capacitive circuit or the capacitor, so from voltage and current, we know that in capacitor the voltage leads and current lags. This is the current and this is the voltage. Alright. In capacitive circuit, okay, current lead I think, yes, current leads and voltage lags. If you forget which quantity lead or lag, then we know that this Li I's. So you can see, my dear students, here the voltage is lagging in capacitive circuit and the current is leading. So we can write the equation as Et is equals to E naught, and this E naught is now 1000 sine omega t, and plus it was pi by 6 already, but the voltage leads by pi by 2, so minus pi by 2. Alright, and then the equation become 1000 sine omega t minus pi by, I think it should be 3 minus pi by 3. Am I right? Kindly check my calculation. Yes, it is pi by 3, and this is the answer. Now the second one, we have to find the power. How you will calculate this power? So could you find the power, my dear students? Yes, we know that the power, it is the E RMS times I RMS into cos phi, and we are having the value of phi already here for the voltage and the current. We are having the phase difference, so we can write the power as well. I hope you understand how to solve this type of question. Let me give you one more question, my dear student, for your practice. Let me grab this one. Now, the next question I will give you, my dear students, for the inductive circuit, because we have solved one question of capacitive circuit. Here, this is your homework. So, after the lecture, you will solve your work. Here, it is an inductor under AC supply. Suppose the inductance, it is 10 millihenry. We have given. Alright. And the value of voltage I am giving now. Thus E is given as, suppose it is 5 sine 100t minus pi by 3. Alright. The two things you have to calculate. One, it is the equation of instantaneous current, and the second, the power dissipated. Okay, this is your homework. My dear students, only 2 questions I have solved today, but in our live classroom program, when I will give you on your class on Microsoft, we will discuss few questions on the basis of this power factor, which are based on the power factor. Okay, my dear student? Alright. So, this is all about today's lecture, my dear students. Thank you very much.